In our video yesterday, one of the problems that we looked at dealt with, I believe it was letter C, where in letter C we had to figure out how much lithium hydroxide we needed to create that solution. It was 19.4 grams of lithium hydroxide. So that's what today's video is about, a little bit more detail about that, about how do you actually make a solution. Let's say you've got some water and you've got some salt. Okay, and you want to create a solution with a certain concentration. Okay, how do you make that solution depends on a couple of things. Number one, how concentrated do you want it to be, and how much of that solution do you need? For example, when we make solutions to use in labs, we have to figure out, okay, how much of the solution do you think the students are going to need? If each group needs 50 milliliters and there's 30 groups, we need 1,500 milliliters. So then we kind of figure out how much do we actually make, what concentration do we want it to be, etc. So in these two examples here, we're going to talk about how we actually make these solutions. So example 1 here says, describe the steps necessary to create 750 milliliters of a 1.25 molar sodium chloride. And remember, sodium chloride is just salt. So a 1.25 molar salt solution. So notice right away they give us the volume and they give us the concentration. Really, anytime they give you the concentration and the volume, and remember when I say concentration, it means molarity. So anytime they give you the molarity and the volume, you know that you're going to be taking those two things, multiplying them to get the moles. Okay, and so that's the first thing that I do here is I take my 1.25 molar and then I multiply by that volume converted to liters. When I multiply those together, I get 0.938 moles of NaCl. Okay, and again, going back to the last video, remember that was the first thing we did here, was we took the concentration, we took the volume, and we had to get moles of lithium hydroxide. Okay, same thing here. Anytime they give you the concentration and the volume, you've got to find moles first. Now that we have the moles, we can convert those moles to grams using the molar mass of sodium chloride. Okay, so in this case, we've got 0.938 moles of NaCl from here. We go to the periodic table. The molar mass of sodium chloride is 58.5 grams per mole. We take 0.938 and multiply by 58.5 and get 54.8 grams of NaCl. Now, that's one of the things I'm going to look for. If I ask you a question like that on a quiz or a test and I say, how do you tell me the steps to make this? One of the things I'm going to look for is, do they have the correct amount of the solute? Remember, NaCl is the one getting dissolved, so it's the solute. So that's the first thing I'm going to look for, okay? And really, everything after that is pretty straightforward. You're going to use what's called a volumetric flask. Okay, this thing right here is a volumetric flask. This one's a 500 milliliter one. In the problem, it says 750. It doesn't matter. Okay, but they're all pretty much the same. See, there's a line right here, and that line only measures 500 milliliters. Okay, and so what that means is a volumetric flask isn't good for measuring, in this case, if it's a 500 milliliter, it's not good for measuring 490. It's not good for measuring 510. There's one line on it, and that one line represents the 500 milliliters. Okay, so basically you get the mass of NaCl that you need, and you put it into this volumetric flask. And then basically you just add water until you probably add some water and then mix it up and dissolve it all, and then you continue adding water until you get to this line. Okay, and that line again represents 500 milliliters, or if it was a 750 milliliter volumetric flask, it would represent 750. Okay, when that water gets up to the line, let's say here's our line, there's our 750 line. Okay, what the water does, water is attracted to the glass, and so it's going to climb the walls a little bit, and so water is going to basically look like this. It forms a little bit of a curve. Okay, and again, that curve is called a meniscus, and so you want the bottom of that curve, you want the bottom of the meniscus to be right on that line. Okay, that's what it should look like, is the bottom of the meniscus is touching that line, and that gets you, again, as close to 750 milliliters as you can get. So the two things I'm going to look for are, do they have the right mass of the solute? And then do they say, you can't say add 750 milliliters of water, because remember, it's the solution. And that sodium chloride is going to take up some of that space. So you've got some sodium chloride in here already, and now you're going to add water. How much water? It doesn't matter. Okay, what matters is you're going to get 750 milliliters of solution. So don't say add 750 milliliters of water. You say add water until you reach 750 milliliters of solution. Okay, let's look at another example. Example 2. Describe the steps and list the materials needed to create 1,000 milliliters of a 0.455 molar solution of AlNO33. So again, like always, we're going to start with our concentration, moles per liter. We're going to multiply, that's in milliliters, so we're going to move that decimal point 3 spaces to the left. So that's 0.455 moles of AlNO33. And now we need to convert those moles to grams. So aluminum is 27, nitrogen is 14, there's 3 of them, that's 42. Oxygen is 16, and there's 9 of them, that's 144. That equals 213 grams per mole. So I can write 213 grams in 1 mole of AlNO33. Multiply that by 0.455, and I get 96.9 grams of AlNO33. So certainly one of it says list the materials. One of the materials I'm going to need is I'm definitely going to need a balance, because I have to weigh that aluminum nitrate. Okay, I'm definitely going to need a 1,000 milliliter volumetric flask. Okay, and then even here it talks about I'm definitely going to need some water. I don't know if that's a material or not, but we're definitely going to need some water. Okay, and then we're going to use, you can at the very end basically use like a little eyedropper, okay, to get that last little bit so that the bottom of that meniscus is on that line. Okay, so we're going to take 96.9 grams of AlNO33 and we're going to add it to the 1,000 milliliter volumetric flask. Okay, and then we're going to add water and dissolve the AlNO33, and then we're going to continue to add water until there is 1,000 milliliters of solution. Okay, and then you will have created a 0.455 molar solution of aluminum nitrate. Okay, and guys, this is exactly how we do this when we actually make solutions. When we need to make some aluminum nitrate, we have some powdered aluminum nitrate, so I have to figure out how much of it do I need, and then I get a volumetric flask, I put the amount in there, I add some water, I dissolve it, I add the rest of the water, okay, and then again we're going to put this into a bottle, and on the outside of that bottle I'm going to write 0.455 molar AlNO33. So me or any other teacher who comes to use that aluminum nitrate knows what concentration of it is, and so that it's not too concentrated, or if they need a certain concentration, they know what concentration of that aluminum nitrate is.